In this video, we are going to discuss angular properties of circles. Now, the first property this is the center of the circle. Property number one. Okay, property number one. This property center does not matter actually. So, suppose there is a chord and a chord, single chord subtends multiple triangles, or we can say it subtends multiple angles at the circumference of the same circle, as you can see here. Let us consider this point as A, this point as B, and this point as C. And let us consider the length of the chord as the name of the chord as PQ. So this chord is subtending three angles at the circumference of the same circle. So whenever you see a common chord subtending the angles at the circumference, the angles are equal in value always. Because for angle C, the chord is PQ. For angle A, the chord is again PQ. And for angle B, the chord is again PQ. So common chord subtends same angle at the circumference of the same circle. Theory number one. Whenever you use this theory, you will mention proper statement for it. Angles subtended by the same chord. And you can mention the name of chord specifically. At the circumference. Angles subtended by the same chord PQ at the circumference. Why these angles are equal? Because angles are subtended by the same chord. Angles are subtended by the same chord PQ at the circumference. Okay. You will write angle A equals to angle B equals to angle C. Reason: angles are subtended by same chord PQ at the circumference. Next theory. Theory number two. Now, according to this theory, suppose again there is a chord, it subtends an angle at the circumference and also it subtends an angle at the center. Now here it's the center of the circle named as letter C. Now let us consider the chord as AP and this subtended angle as D. So here in this case there are two parts. This angle is subtended at the circumference, whereas this angle is subtended at the center, as the marking represent on the screen. Um, the angle subtended at the center of the circle will be double the angle subtended at circumference. If here it's x degree, here it must be 2x degree. Okay. Now, for this, what should be the correct statement to be written as reason? The angle subtended at the center of the circle is twice the angle subtended at the circumference of the same circle. This is the reasoning part for this property. I hope I am clear. Now let us move on with the third property. Any quadrilateral whose all the vertices lies on the circumference of the circle. Any random quadrilateral whose all the vertices lie at the circumference of the circle is considered as cyclic quadrilateral. Here we will say that ABCD is cyclic quadrilateral. Cyclic quadrilateral. And the special property of cyclic quadrilateral is that opposite angles sum up to 180 degree. And these are not equal actually, but opposite angles sum up to 180 degree are supplementary. That means angle A plus angle C will be equal to angle B plus angle D will be equal to 180. The sum of these opposite angles will be 180 degree. If angle B is 100 degree, then angle D must be 80 degree. Now another property, property number 4. Now once again, any quadrilateral, one dimension is extended, is produced further, as you can see. Now suppose this is the same quadrilateral ABCD and DC is produced to E. Now this angle will be equal to interior opposite angle. Why, sir? Why those two angles are equal? Because if angle BCE is considered as x degree, angle BCD must be 180 degree minus x degree. Sum total minus x degree will give you this path. Also, we know that since ABCD is a cyclic quadrilateral, so is cyclic in short. Since ABCD is cyclic, angle C plus angle A must be 180 degree. Angle C, this is what we calculated out, 180 minus x degree plus angle A equals to 180 degree. 180 gets cancelled out and angle A is equal to x. Finally,